Another example of nucleophilic substitution is the reaction between haloalkanes and ammonia. In an exam question, you'll see that it says the ammonia is in excess, and that's a clue to getting the mechanism for this right. So you can see here, the ammonia has a lone pair, so even though it's not negative, it's still a nucleophile and attacks the positive carbon. So a bond is formed between the carbon and the nitrogen, and the bond between the carbon and the bromine breaks. The intermediate that's formed is like this. So a bond is formed between the carbon and the nitrogen. The rest of the molecule stays the same, but because both electrons have come from this lone pair and there's no negative charge here, a positive charge is left on the nitrogen as the electrons are used to form that bond. The bromine leaves as a negative ion. Now, as I said, in the exam question it'll say ammonia is in excess, and that's because it attacks the molecule again. This is now not acting as a nucleophile, but as a base. And a base wants to take a proton, a H+. So it takes a hydrogen by forming a bond between the nitrogen and the hydrogen, and the electrons in this bond are transferred to the nitrogen, cancelling out that positive charge. The product that's now formed is an amine with an NH2 group on it, and the rest of the molecule again staying the same. So this would be methylamine, and the other product that will form would be NH4+, as the NH3 is taking H+ from our intermediate, Br-, like so, ammonium bromide.